today's class, we are going to do theorems on moment of inertia and the applications, right? So there are two theorems on moment of inertia. One is parallel axis theorem. Please write the name. And second is perpendicular axis theorem. See, till now, we have learned to calculate the moment of inertia of rigid bodies when the axis is passing through the center of mass. So if the axis is passing through the center of mass, you can easily find moment of inertia, right? But what if the axis is not passing through center of mass? Then what? If the axis is not passing through center of mass, then how will we find moment of inertia? In that case, we apply theorems. Okay, so there are certain theorems which helps us to answer the above questions. The first among them is parallel axis theorem. Okay, so it states that the moment of inertia of a rigid body about an axis is equal to the moment of inertia about a parallel axis passing through its center of mass plus the product of the mass of the body and the square of the distance between the two parallel axes. Please write the statement. This is important. We have an object of mass m. ठीक है, यहाँ आपको दिख ही रहा है ना? मुदित आपको विजिबल है ये?
Yes.
Okay, so we have an object of mass m, and this point is the center of mass, and this axis is passing through the center of mass. Okay, now we can, rotate this object like this. Axis of rotation कहाँ से pass हो रहा है? Axis of rotation is passing through the center of mass. Okay, अब parallel axis theorem में क्या है? What if I want to find moment of inertia at certain distance from this object? What if I want to find moment of inertia on this axis? About this axis, what would be the moment of inertia? This is the question. So for this, we apply parallel axis theorem because you can see that here in case we have two different axes. One axis is passing through the center of mass and other axis is the axis about which we have to find moment of inertia I. Okay, so we'll use parallel axis theorem. Parallel है ना ये दोनों, तो हम इसमें parallel axis theorem use करेंगे. अब ये क्या है? Read the statement again. Moment of inertia of a rigid body about any axis. किसी भी रिजिड बॉडी का मोमेंट ऑफ इनर्शिया किसी भी एक्सिस के अबाउट किसके इक्वल होगा? इट इज इक्वल टू द मोमेंट ऑफ इनर्शिया अबाउट अ पैरेलल एक्सिस पासिंग थ्रू द सेंटर ऑफ मास. मतलब मोमेंट ऑफ इनर्शिया अबाउट दिस एक्सिस, लुक एट दिस, मोमेंट ऑफ इनर्शिया अबाउट दिस एक्सिस इज इक्वल टू द मोमेंट ऑफ इनर्शिया अबाउट द एक्सिस which is passing through the center of mass and plus means we are adding something to it, the product of mass of the body, mass of this body and the distance, square of the distance between these two parallel lines. And how do we find the distance between parallel lines? We take the shortest distance, right? Shortest distance is the perpendicular distance. So we'll take m into distance between these two, है ना, उसका square. So m, you can take distance as h or you can take distance as r, it's your choice. So I is equal to moment of inertia of about this axis is equal to moment of inertia of the axis which is passing through the center of mass plus mass of the body into square of the distance between them. Clear? Easy? Yes? Okay, now please इसको ड्रॉ करके कर सकते हो अपने आप से, जैसे मैंने आपको शो किया उसको ड्रॉ करो. ऐसे सेम वैसे ही बनाया, विनम्र इतना ब्लाइंडली फॉलो कर रहा है. गुड. वैसे ही अंडा बनाया आपने बिल्कुल. आप कैसे भी बना सकते थे उसको, आप उसको कोई भी शेप दे सकते हो, ठीक है? ओके, consider lamina with its center of mass at C. So we have, something, a system, and C is the center of mass, and we have another point here, point O, okay, about which we're going to find the moment of inertia. So because C is the center of mass and, axis which passes through the center of mass, we have one axis which passes through the center of mass, and moment of inertia we can write as I with the subscript C.M. C.M means center of moment of inertia, about center of mass. Okay, now we have to find moment of inertia about O. So we can write I naught for this I0. Okay, IO, क्योंकि हमने उसके about moment of inertia find करना है. So we can apply parallel axis theorem here. Let h be the distance between these two axes which are parallel, है ना? So we can write क्या लिख सकते हैं बताओ? I naught is equal to I O is equal to, because it's about O, is equal to ICM plus mh square. M is the mass of the system. H square of the distance between the two axes. One axis is passing through the center of mass, और कोई दूसरी जो एक्सिस है वो कोई भी आर्बिट्रेरी आप ले सकते हो, ठीक है, बट एक एक्सिस आपकी सेंटर ऑफ मास से पास करनी चाहिए, ठीक है. So but how is this formula derived? Now this is a question, so let's see. Take a small element of the lamina of mass Tm situated at P. If we consider a small mass at point P of mass Tm, Dm is a very small mass. Okay. Now the distance of this point or this point mass from these two points O and C, we can take from C, we can take distance as R naught, and from O we can take distance as R. Okay. So OP is equal to R and CP is equal to R naught. Now draw a perpendicular PM and extend this OC to M. So PM is perpendicular on OM. Okay. So let's say that this CM is X. Okay, we can consider this CM as X. Okay, so consider the same diagram, and here we have C. We can find moment of inertia. किसी भी point mass का किसी भी axis से, जैसे suppose we have a point mass here, and this is the axis of rotation, and this is the point mass. It is at certain distance, let's say R, from the axis of rotation. Then how do we find moment of inertia? We take the mass and square of the distance, है ना. Axis of rotation से किसी भी point mass का moment of inertia कैसे find करते हैं? Mass into square of the distance. ठीक है. तो अगर आपको moment of inertia find करना है about O, तो आप कैसे find करोगे? It's I naught. Okay, कैसे find करोगे इस axis के about? We can write integral r square dm. Why integral? We're doing first we differentiate and then we integrate, as we always do in physics. Okay, so integration dm is the mass and r is the distance of the point mass from the axis of rotation, and we take square of the distance. Similarly, we can write for C. So moment of inertia about C, about center of mass, is denoted by ICM about this axis. Okay, about this axis. Look at this. So this point C is at distance r naught from P. है ना? This point C is at distance r naught from P. So again, we can write integration r naught square dm. Easy. Okay. So now consider this triangle OPM. In this triangle OPM, this is a right angle triangle. We can see we can apply Pythagoras theorem here. So OP square is equal to PM square plus OM square, right? And what is this OM? OM is OC plus CM. We can write H plus X whole square for this. Okay. And OP is R square. OP is R square and OM is H plus X whole square is E plus PM square. This is how we can write. ठीक है. तो अब आपका R square आ गया ये. अब ये कैसे आया ये बताना जरा मुझे. H square plus X square. X square होना चाहिए था. H square plus 2HX plus X square plus PM square. ये R naught square कहां से आ गया? Look at this triangle PCM. PCM. ठीक है. So PM square, look at the cursor movement, PM square plus X square is R naught square. So we have PM square already, and X square will get from this A plus B square by using this. So X square plus PM square is R naught square. ठीक है. कोई doubt तो नहीं है? Okay. So now because I naught is integral R square dm. So in place of R square, we can write this H square plus 2HX plus R naught square. Now we'll integrate them separately. Okay. So integration of H square dm plus integration of 2HX dm plus integration of R naught square dm. Fine. ठीक है. H square बाहर लिख लोगे, dm अंदर. ऐसे ऐसे आप जहां पे जो वेरी कर रहे हैं, देखो जैसे यहाँ पे H is constant, तो H को हमने बाहर रखा, X dm अंदर, इधर R naught square है. R naught square dm क्या हो जाएगा? ICM, क्योंकि R naught डिस्टेंस कहां से था? सेंटर ऑफ मास. ठीक है. And dm is integration of dm is mass of the body. We have small particles of mass dm everywhere. ठीक है. When we integrate all the point masses, all dm's, then we get total mass. ठीक है. Okay. And x dm is equal to 0 because it is the moment of mass about center of mass at equilibrium, which we take as 0. So now we are left with this, and this is the final result. So this is the proof of parallel axis theorem. This is how we prove parallel axis theorem. Okay. So now we have questions. Passing through its center of mass is I naught, and moment of inertia of the same body about another axis parallel to the first axis is I. Then please answer this question. यस, रिलेशन देखो कौन सा बड़ा होगा, आई नॉट या फिर आई, विच इज ग्रेटर? आई इज ऑलवेज ग्रेटर देन आई, I is always greater than I naught. See, I naught is the moment of inertia about an axis which passes through the center of mass. So how do we find moment of inertia about any axis? Moment of inertia about any axis is equal to moment of inertia about an axis which passes through the center of mass plus mh square. We are adding something to it to get moment of inertia about any other axis, right? We add something, that something is mh square. We add something to the moment of inertia about an axis which passes through center of mass to get moment of inertia about an axis which is not passing through center of. Okay, and therefore I is always greater than I naught. Second question is the mathematical statement of the parallel axis theorem is. Please tell me the correct answer. It's sure. Yes. Now we have numerical problems based on parallel axis theorem. Let's try the first question. In the first question, we have a rigid body. We have to find the moment of inertia about an axis passing through O and parallel to the axis passing through center of. Okay, we are given that moment of inertia about center of mass is 20 kg meter square. So about center of mass moment of inertia is given, and distance between O and center of mass is given. It is 1 meter. Mass of the body is given. It's an easy question. ये हो गया होगा, है ना? तो हमें सेंटर ऑफ मास के अबाउट मोमेंट ऑफ इनर्शिया पता है, हमें ऑब्जेक्ट का मास भी पता है, हमें उसका दूसरी एक्सिस वी कैन इजीली फाइंड बाय अप्लाइंग पैरेलल एक्सिस I naught is equal to IC plus mh square and put all the numbers here. IC is given, it's 20, M is given, H is given, so answer is 20 kg meters square, 22 kg meters square. Are you getting the same answer? मुदित बेटा यही आंसर आ रहा है?
Yes.
Great. Easy question था ना? Second question. See, mass is given, it's 3 kg, and about any random axis is given which is parallel to the axis passing through center of mass. It is 25 kg meter square, and we have to find moment of inertia about axis passing through center of, and distance between the two axes is given. It is 0.5 meter. Those values, and then we'll use the formula. I naught is equal to IC plus mh2. Okay, so we can write IC as I naught minus mh square. It's square, it's not subscript, it's superscript. Okay, okay, so put the value. The answer is this 24 point. Why are you talking? Why have you started? Have you done the question? अभी हुआ नहीं है ना, बातें शुरू हो गया था, क्या आंसर आया बताया नहीं, गलत हो गया। तो किस किस का रॉन्ग हुआ है ये? इधर बॉयज, देखो आपने फास्ट किया, आपका रॉन्ग हो गया। Mudit, have you done this?
Yes.
Okay. Perpendicular axis theorem. It's very easy, very very easy. इससे easy कुछ भी नहीं है, इतनी easy है ये, ठीक है? So now if one axis is perpendicular, then how will we calculate moment of inertia about that axis? And see, for this we need to use perpendicular axis theorem, and it states क्या होता है perpendicular axis theorem? It states that moment of inertia of a plane lamina about an axis passing through a point and perpendicular to its plane is equal to the sum of the moments of inertia of the lamina about two perpendicular axes passing through the same point and in the plane of lamina. Please write the statement first. The statement is important. Sometimes they ask you in exam that please state perpendicular axis theorem. इसको कॉपी पेस्ट करके आओगे ऐसे, ठीक है? अब देखो कैसे करते हैं perpendicular axis. Look at this. See, here we have three different axes about which we can, find the moment of inertia. All these three axes are mutually perpendicular to each other. Please, यहाँ देखो पहले. You can write. ठीक है? We can find moment of inertia about any axis. इसमें क्या करते हैं हम? We consider a plane, and we know that plane means either xy or yz or xz. Any plane we can choose. So if we are choosing xy plane, so this is the xy plane. Let's consider that this as our x-axis, this is the y-axis, and this is the z-axis. ठीक है? So moment of inertia about z axis is equal to moment of inertia about x axis plus moment of inertia about y axis. बस खत्म. Iz is equal to ix plus iy. ix plus iy is equal to iz. इजी है. इससे इजी क्या होगा? ठीक है, ये मैं बाद में बताऊंगी ये क्यों है. ठीक है, तो we take two axes which are in the same plane and one axis is perpendicular to the plane, right? तो उसके about we can find moment of inertia by adding the moment of inertia. So Iz is equal to Ix plus Iy. So here we have, taken a point P, and this point P, let the coordinates of this point P be x, y, z. So this point P lies in the lamina. Okay, it lies in the lamina. So it is a distance x from y-axis and y from x-axis. You can see this point P is at distance x from y-axis, and this is at distance y from x-axis. Okay, and r is the position vector, or r is the distance from the origin, we can say. अब इसको कैसे लेंगे? Consider a particle of mass m at pxy. Let it be at distance r from z-axis. Ix, Iy and Iz are the moment of inertia of the plane lamina about xy and z-axis respectively. जैसे मैंने बताया आपको. So let x and y lie in the plane of the lamina and z-axis perpendicular to the lamina. देखो अब आपका जो Ix है, we can write Ix as summation over my square. Why my square? एक बार देखो यहाँ पे Ix as summation over my square. देखो इसमें जब आप Ix फाइंड कर रहे हो, इसका मतलब ये है कि आप मोमेंट ऑफ इनर्शिया फाइंड कर रहे हो अबाउट x एक्सिस, and we have a particle at point P, and this particle is in the xy plane. This point P is in the xy plane. किसी भी पॉइंट का एक्सिस से डिस्टेंस कैसे निकालते हैं? mass and square of the distance, product of mass and square of the distance. This is how we find. तो यहाँ पे अगर कोई पार्टिकल है पॉइंट P पे, स्मॉल मास है उसका, और उसका डिस्टेंस एक्स एक्सिस से परपेंडिकुलर डिस्टेंस कितना है? y. So m into y square. So we have considered just small mass in the lamina. What if we consider all the point masses which are there in the lamina? Then we need to either you do the summation or you can integrate it. This is how we do. Similarly, if I want to find moment of inertia along about y-axis, then mass and multiply by square of the distance. But this time square of the distance means x square. X square. ठीक है? And what is this point O? O क्या है? Origin लिया हुआ है हमने, वहां पे हमने x, y और z एक्सिस को दो, राइट? तो अब यहाँ पे वो सेंटर ऑफ मास की पोजीशन को हम उसको लोकेट कर सकते हैं कि वी हैव सेंटर ऑफ मास लाइज एट ओरिजिन. ठीक है, तो अब ऐसे ही जो Iz लोगे आप, तो वो क्या आएगा? समेशन ओवर एम आर स्क्वायर, है ना? Iz क्या आएगा? Summation over m r square, and r square is, look at this triangle, we have this is x, this is y, so r square is x square plus y square. R square is x square plus y square, so we can write like this. ठीक है, so summation over x square mx square plus summation over my square. This mx square is ix and this my square is my square is ix and mx square is iy. ठीक है, तो आपका Iz आ जाएगा यहाँ से ix plus iy. इजी. ठीक है, कैसे करेंगे? Who is going to explain? ये तो इजी था. हमने एक पॉइंट कंसिडर किया, ठीक है, ये एक लामिना लिया, एक्स वाई प्लेन में है. हम किस एक्सिस के अबाउट मोमेंट ऑफ इनर्शिया फाइंड कर रहे हैं? जेड एक्सिस के अबाउट मोमेंट ऑफ इनर्शिया फाइंड कर रहे हैं. ठीक है, अब ये पॉइंट पी कहाँ लाई करता है? एक्स वाई प्लेन में लाई करता है. तो कोऑर्डिनेट्स क्या है इस पॉइंट पी के? एक्स वाई है. एक्स वाई का मतलब क्या होता है? इट इज अ डिस्टेंस एक्स फ्रॉम वाई एक्सिस एंड वाई फ्रॉम जेड एक्सिस. Sorry, y from x axis and r from origin. ठीक है, so this is a small mass, dm जैसा mass in the lamina. ठीक है, तो summation sign क्यों लगाया? Because in the lamina we have similar type of masses. We have n number of masses, we can say, है ना? तो हमने यहाँ पे क्या लगा दिया? Summation लगा दिया. तो m, अगर हमने ix निकालना है, moment of inertia about x axis, तो moment of inertia about x axis, उसका mass और स्क्वायर ऑफ डिस्टेंस, डिस्टेंस क्या है, वाई स्क्वायर है। ऐसे अबाउट वाई एक्सिस निकालने के लिए एम एक्स स्क्वायर करोगे। आईजी कैसे निकालोगे, समेशन ओवर एम आर स्क्वायर कर दोगे। आर स्क्वायर क्या आएगा, एक्स स्क्वायर प्लस वाई स्क्वायर इक्वल आएगा, बिकॉज यहाँ पे हम हाइपोटेनियस वाला पाइथागोरस थ्योरम लगा रहे हैं। ठीक है, अब इसको ओपन किया, एक्सपैंड किया, वैल्यूज पुट कर दी, एम एक्स स्क्वायर के प्लेस पे आई वाई, एम वाई स्क्वायर के प्लेस पे आई एक्स, आपका आई जी इज इक्वल टू आई एक्स प्लस आई, इजी एंड सिंपल डेरिवेशन आई। ठीक है, now we have questions based on this. The perpendicular axis theorem says that 16 kilogram meter square and moment of inertia about z axis is 20 kilogram meter square. So the moment of inertia about y axis is good. ठीक है, आई वाई कैसे फाइंड करोगे, आई जी माइनस आई एक्स। We have a rigid body, it is rotating in xy plane, its moment of inertia about x-axis and y-axis is given. We have to calculate moment of inertia about z. It's an easy question. We'll simply add these two to get moment of inertia about z. Put the values here and you'll get your answer. Okay, on a plate, so we have a square plate, okay, and I is the moment of inertia about an axis passing through the opposite corners of plate. The moment of inertia of the same plate about an axis perpendicular to the plane of plate and passing through its center is. ठीक है, आपको एक स्क्वायर प्लेट गिवन है, ठीक है, उसके अपोजिट कॉर्नर से जो एक्सेस पास होगी उसका, उसके अबाउट मोमेंट ऑफ इनर्शिया हमें पता है। सेंटर से प्लेट के परपेंडिकुलर जो एक्सेस पास होगी उसके अबाउट मोमेंट ऑफ इनर्शिया क्या होगा, दिस वी हैव टू फाइंड आउट एंड हियर योर ऑप्शंस आर 1/2, 1/√2, √2i एंड 2i। इसको लॉक करें, बताओ। 2i कैसे फाइंड करेंगे, we have to find moment of inertia about an axis which passes through the center and perpendicular to the plane of plate, means about z axis. ठीक है, so iz is ix plus iy, we know। देखो अपोजिट कॉर्नर्स के अबाउट, अपोजिट कॉर्नर्स मतलब डायगोनल्स है ना, अपोजिट कॉर्नर्स मींस डायगोनल्स। ठीक है, so we know ix and iy they are equal to I, बिकॉज अपोजिट कॉर्नर्स जो होंगे उसके वो आइडेंटिकल है, डायगोनल्स आर इक्वल इन स्क्वायर, diagonals are equal and they bisect each other at 90 degree, they are perpendicular bisectors as well. So ix plus iy is equal to iz, so iz is equal to ix plus iy। अब ix भी I है, iy भी I है, तो I plus I is iz, iz is 2i। अच्छा, अब अगर एक क्वेश्चन और ऐड करते हैं इसमें, ठीक है, अगर आपको मैं ये बोल रही हूं कि फाइंड द मोमेंट ऑफ इनर्शिया about an axis which is, you know, passing through this vertex and perpendicular to the plane, then how will you find? Let's add this. Now this time we have to find moment of inertia about an axis which is passing through one of the vertices of the square plate and it is parallel to the z-axis. And can you find the moment of inertia? You can take a side of the square as a, small a. We can take side of the square as small a. This is small a. Okay, but this time we have to find moment of inertia about this axis. We can consider this axis as AB. See, this is a square plate. We have a symmetrical figure, so we can assume that center of mass lies at the center where the diagonals cut each other. So let this point be origin, and here the center of mass also lie. So this axis IZ is actually passing through the center of mass, we can say. So how will you find moment of inertia about AB now? A is the side. We can find length of the diagonal. Length of the diagonal first. It is root 2a root 2. Yes. Now we can find moment of inertia about AB as equal to moment of inertia about z-axis plus mass a by root 2 whole square. So this is Iz is 2I plus ma square by 2 is the answer.